Hello everyone, it's February 28th. I think today is going to be March the 1st. We didn't do sort in array. What do you mean by sort in array? Given what? Given an array of integers, sort the array in ascending order and return it. You must solve the problem without using any built-in functions, and with the smallest space complexity possible. Yeah, screw you. They just screw you, right? All right, now let's do it. What's the best sort? Quicksort. All right. Now let's do quicksort. Can you write quicksort? I'm not sure if I can write quicksort. We'll see if I can do quicksort. Quicksort. Okay, let's quicksort this stuff. I think we'll pick the first one, right? And then everything that's smaller than this will stay on this side. Everything that's larger will go to the end. So what we're gonna do is, let's see. Let's go through the whole process. So we have a left and a right. Right, we have a left and a right. And what we're gonna do is, if left is smaller than the start, then we will move left forward. If left is larger than, then we will swap left low and high, and I will do it again. I'll swap and then move the right forward, and I will keep doing this until we hit a point, right? Until the low and high meet each other, right? Low and high meet each other, and the point where they meet each other, we need a check, right? To see if, hold on, like if I swap, so it's bigger come here and I go forward, right? And what if the swap is still big? Then we need to see, we need to see if this one is bigger or smaller. If this one is bigger, then we do one to the left. If it's smaller, we do as it is, and then we swap with the original. And then we'll have two halves, the left half and the right half. Then we do this thing all over again. So what we're gonna do, and this is actually in space, right? It's in space. So what we can do is to do a def quicksort, right? Quicksort. We need a low and high, right? And then we'll return nothing. This one will return nothing because we'll do everything in space. And then we have a low and a high, right? And then just start low and a high, and then we'll pick the first one, right? I'll pick the first one. Then we just say while low is smaller than high, right? If nums low, right, is smaller or equal to nums anchor index is low, okay, smaller index, right, then low plus equal 1, okay, else nums low, nums high equals nums high and nums low, right? We swap the two, and then high minus equal 1. And then we do it again. And then blah, blah, blah. Once we're done, we say if num's low, right? If that is larger than num's index, then low minus equal 1. And then we say num's index, num's low equals num's low and num's index. So index now is in the sorted position. Then we can call quicksort index as a start and low minus 1. Right? That's the left half. And a quicksort low plus 1. Ooh wee! I need to know the I and J. So this would be I, and I. So low plus 1 and J. Okay, then we're gonna call quicksort 0 and len nums minus 1. And it will return nums. Alright, let's see if this works. Oh, there are a lot of test cases we can do. Length is 1. 1, 2, 3, 4, 5. Right, we can do that. Oh, we'll actually do 1, 2, 3, 4, even, odd. And then 4, 3, 2, 1. And that's about it. That's everything we want to test. Alright, something is not right. What happened? Oh well, something happened. Because I don't have an end case. So eventually, if low is equal to high, yeah, now we just return. That's the end case. Ooh, we're still not right. What the hell? Oh, what happened? Which one? The first one? Alright, we have to. I thought we'll be very fast. I thought we don't have to worry about any of these. I'm very wrong. But it's okay. It's okay. We can just take a look at where did we got it wrong. Okay, let's just do this. Oh, okay, I haven't done this one. It's nums. Sort array. What happened? Zero and minus 1. Ooh, that is true because both are, But hey, hold on. How is that even possible? It is possible. If num's low is larger than num's I, right? So we say low and minus 1, then low is equal to I, and I will swap, right? And after swap, we say low is in the right position. So it should be larger than. Okay, so I just need to do this one larger than. Looks good. Try this. Oh no. Oh no. Really? Are you kidding me? So we need to randomize it, right? All right, that's stupid. Why would this one not work? Because it's I don't know. If it's smaller than that, then I swap. Huh. Interesting. Why would this one be slow though? Yeah, these are all easy to deal with. Oof. Ooh. I don't know, man. I think we can just get low and high and just take a look. Ah, Lord, it doesn't really give us. Zero to the end. Okay, we get a half. So it's not random enough. Not random enough. How would you get a random enough? Shuffle. Shuffle. Do we have a shuffle? Actually, I don't remember. Don't have shuffle, huh? Not it to turn a random. Yep, we have shuffle. In place. That's good. Import random. Okay. We can shuffle every single time. Right? That is going to take a long time, so I'm not going to do that. So we're going to say random.shuffle nums. Okay. That will be much faster. Okay, so we'll do this. We'll shuffle it. So break away all the pre-existing things in structure. It still takes some time, but I think this will pass. I hope. I hope. Oh no. Oh no. Oh. Lordy. Lordy. All right, this is actually not simple. It's not simple at all. Oh, I screwed this thing, man. Repeated value. All right, we have to handle repeated value. God. Okay, we have to handle repeated value. So this is still valid, right? So what we need to do is, I need a counter. So we can shuffle it. Now we can just shuffle the counter. So we say counter or equals to counter nums, and then keys equals list counter.keys, right? And then we will shuffle the keys, right? And then we will do the keys, quicksort the keys. So now we are finished. And then what we're gonna return is for keying keys, because it's sorted. We're gonna say key times counter key, right? And then the whole thing, we're gonna do this. I'm gonna chain it. Now we're gonna do a list and return this. Okay, from it to tools, import chain. That is not what I had expected. Oh, because it's nums. Dude. Num list. List nums. Okay. Now we have to do list nums. Okay, and then we're going to pass list nums. List nums. That's fine. And keys. Okay. Okie dokie. Okie dokie. How about now? Now you're happy? Now we happy. All right, now we happy. Now we happy. Now we happy. Oof. It's not as easy. Oof. Not as easy, huh? As I had expected. Because of some tricky test cases. Quicksort. Quicksort depends on the input array to be as randomly ordered as possible. Right. Thus, we need to shuffle it. To make it shuffle it to speed up, to take advantage, right? Take advantage of divide and conquer. On the other hand, we have to also deal with duplicates, right? In case the entire input array consisting of the same value, same number, we use a counter which allows us to sort only the unique values. Combining these two tricks, we are able to pass the OJ. Oh, and login. Okay, that's good. Oh, we need to use merge sort. How do you do merge sort? Oh, merge sort. This is just useless interview questions, but I forgot about merge sort. I forgot about heap sort. Heap sort. I remember quicksort. Counting sort. Oh, you can do counting sort. Can you do counting sort? 5 times 10 to the 4. Maybe you can. Maybe you can do counting sort. But counting sort will require a giant array, so probably not the best one to use. It's fast, but I think the requirement is be as small as space complexity as possible. I don't think counting sort is good. Radix sort. I never really fully understand radix sort. Maybe that's the one to go for. I shall be able to do merge sort. Oh yeah, I remember merge sort. Split into, and you're merging them. I should do merge sort. I can try that. Heap sort. Dude, are you implementing a heap? Alright, we can do merge, which is fine. Heap. I know you have to build a heap yourself. Dude, who's gonna build a heap? He does build a heap. Gosh. Nah, counting. I don't know about accounting. I forgot how to do counting. 3, 1. Let's do 0. 1 is 2. Yeah, so you go through. If it has something, you just repeat it twice, right? And then you go to -2 is nothing, -1 nothing, so you just skip. 1, you have 2, so you put 2 1s. Counting sort. Radix. Hold up. Sort based on unit place. Oh, that's radix. Unit place. So that's a bucket sort. So we have 0, Oh, it doesn't really matter. We just do this is 0, put in 0, put in 0, put in 0. So based on the 10th. So we go to the second position. Third position. Oh, interesting. D is the maximum number of digits. That's the how many rounds we need. B is the size of bucket. Oof. Oh, it's called pivot. Oh, random. Oh, that's good. I forgot about this. Oh, that's how to do randomized. Update. Better way to randomize. Only need to randomize the pivot. Therefore, we can do randint pivot, right? So pivot, so it goes to random dot rand int low and high. Okay, then list nums low, list nums pivot equals list nums pivot, list nums low, and then pivot and end. Start and end. Okay, I will be start. It's more clear. This will be end. Then we don't have to randomize this. Let's see. Does it work? Oh, it works. Probably not as good, but it's all right. It's all right. Okay, so now what we need to do is I don't want to do the other two. I can implement them, but I just remember, right? Have quicksort. Oh, the merge sort. You should be able to remember merge sort. And I don't want to implement heap sort because I don't want to implement heap because I forgot how to implement heap. How do I implement heap? It's a tree, right? Heap is a tree. Yeah. So if it's main heap, if we push a new thing in, we push it to the end, and then we compare to the parent. If it's smaller than parent, I go up. If it's smaller than parent, I go up all the way until I cannot go up. Okay, that's actually easy, right? And heapify, we can be as easy as just pushing things into the heap. We push a node, we push another node. If it's smaller, we swap. I push another one. If it's smaller and it's gonna be a binary tree. Yeah, I remember now. But no. That's it. That's all I want to do. Just we have a little trick to do this. But it's good. I mean, remind me of the merge sort. I completely forgot about merge sort. I don't think I'll ever do heap sort, but you can do merge sort, that's fine. Counting sort, that's okay. I can call it counting sort, it's just bucket sort. Yeah, I can do bucket sort. Radix sort. With radix sort is actually pretty good. I don't think I ever done radix sort. Like program it myself. Could be fun. Yeah, that could be fun, but I don't want the fun. Nah, I don't want it. Screw this. Count collision of monkeys on a polygon. Ooh, 424 dislike. 425 dislike. Jeez. A regular convex polygon with n vertices. Vertices are labeled from 0 to n-1 in a clockwise direction, and each vertex has exactly one monkey. Uno mono. Following figure shows a convex. Oh, a polygon doesn't really matter how many vertices there are. There could be more. Each monkey moves simultaneously to a neighboring vertex. A neighboring I can be in the clockwise direction, or I plus 1, 2, 3, 4, 5, 6. Yeah, if you plus 6, you will return to the same position. So -1. So plus and -1 in a counterclockwise. That is correct. A collision happens if at least two monkeys reside on the same vertex after a movement or intersect on an edge. Return the number of ways the monkeys can move so that at least one collision happens. That each monkey can only move once. So each monkey moves once, and you want to find all the ways that can lead to collision. So maybe we can do what's the total, how many ways you can do without collision? Which you can do in one, right? So is that problem equivalent to finding the total number of ways to move the monkeys? Each monkeys can move two ways, either front or back, right? So if we have 3 vertices, then we have 8 ways to move, right? Each one has 2, and we can have everyone move counterclockwise. That's one way to avoid, and clockwise another way to avoid. So that's 2 to the 3 minus 2, which is the first one. And the second one is 2 to the 4 minus 2, which is 14. That's why people don't like it. Why? Why all the hate? I think these questions are fun. The intuition is just like, it's so hard. It's very hard to find the it's very difficult to really figure out all the different ways to move to cause collisions, but it will be very easy. No, you do not. No, you do not. No, you do not. This is gonna time out. Okay, so we need to find a way to efficiently do this. So we need to write. Okay, so we need to write a way. I did this before. I don't remember. It's power, right? It's power. You can do a smart way to do power, but how do you do mod? I forgot mod. What's the mod? Modulo multiplication. I forgot. Multiplication. Khan Academy, save me. Oh, that's probably not the best one to go for because I just want to know the rule. A times B mod C equals A mod C times B mod C mod C. A better way of do 2 to the n. What is the way, man? Okay, so first of all, mod is 10 to the 9th plus 7. While n? Maybe. What's that? While n? The rest is 1. Now the rest should be 2. Okay, n minus equal 1. So that's already raised to 1 power. And then we're going to say if n is this is even, then rest plus equal to rest, n divided equal 2. Else rest times equal 2 and n minus equal 1. Is that right? I have no idea, man. I have no clue. Then we'll return rest minus 2. Alright, so we have 3 will return 6. 4 will return 14. Yeah. Alright. That's people don't like it for another reason. Okay. So 4. So for 4, I say if I don't do this part, then yeah, the starting position, I don't think it's right. I forgot how this is done. Maybe it's larger than 1. I remember this happened in the past. I remember. Ah, God. No. There is a way. There is a way. I remember if this times equal to 2 and this times equal to res and divided by nope. How about option 1? I'm just trying different things. Yeah, it just doesn't work. Oh, God. Two to the, power, right? So if it's 1 power, that will come out. If it's 2 power, if it's 3 power, man, how do we do this? I don't even know. Quick power algorithm. I forgot. Fast power. Oh, you raise the base. Oh, you raise the base. Base power mod. You raise the base. Hold on. So res will be 1. Let's see if we can code it. So res is 1, right? So while n, we say if this, then res times equal to base, right? And yeah, times the current base, and then n minus equal 1. Else should be the base times equal to base. We raise the base and 8 divided by 2. and then we return res. Fast power. Base is 2, power is n, mod is mod. Oh, there's no n. Power. 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 And power. Almost. Almost. Oh no, it's correct, because I forgot the minus 2. Alright, let's see. And you mod here, result. Does make sense, right? Now I don't want to divide the power by 2. Okay, we always divide the power by 2. And then we'll raise the base. Even if we do this, because we do this, so when we do this, because after this, the next step, we'll skip this and do this directly. So, which means this time we can skip this part. And then just basically do this. Right? Because we do this, then we'll go to the next one, which will definitely not do this, which means we'll do this. So this will be the same. Yeah. Intentionally. Alright, so what we can do, res time space mod, right? Time space mod. Because according to this, A times B mod C is A mod C, this mod C times this mod C, which is this mod C times this mod C, right? Which is at the end, it just, all the bases multiplied. Yeah, that makes sense. Okay, so now with this, copy and paste this thing. Learned from this. Yeah, I've done this before. Still couldn't write it from scratch. Alright. Now you should be happy. Now you should definitely be happy. Yep. Hey, what? Wait, what? What? What the hell? Dude. What? How? How, guys? No way. Dude. What the hell? Huh? Yo, you gotta be kidding me. You're saying, oh my god, you're saying we should not do it here. We don't mod here. I don't believe it. It should be this. No, I think it's right. It's just. You see? I know why. I know why. So, oh god. So the result, right? The result is this mod. And basically we're saying this mod is equal to, oh my god. There should be this -2 mod. Okay? Yes, so we have a giant value. -2 mod. So it should be this mod -2 mod this. Right? So the result shall be, because we want a minus, so it should be this plus mod. There we go. Oh, pay attention. The fast power with mod. My return a value. My return a value smaller than 2. Need to add mod to go around again, right? Basically. Smaller than 2. Oof. Ah, I see. I completely see why people don't like it. But of course people don't like it. This is a lot of work, right, to a very simple problem. I see why people hate this problem. It's essentially, right, a test of whether one knows how to write a fast power algorithm. I forgot. I knew, right? I knew its existence, but I forgot how to write it. But that is not all. There is another trick. At the end, when the fast power and the return value, right? The return value of fast power needs to be further processed before -2. All right, how do people? Oh, the power has it. Oh, now I remember. Power has it. Oh, you gotta be kidding me. Power has it. Now this Z modulus. Oh, shoot. We spent so much time forgetting that we can do math.power 2 to n and 10, 9 plus 7 minus 2. Oh, technically we have to do the plus trick as well. Right? Yeah, sure. We can just copy on this. Oh, I forgot. Yes, the power method has it. Yeah, this shall be wrong as well. Math has no power, so I think it's pow. Power expected to. You gotta be kidding me. Oh, it's not math.power. It's just pow. Yeah. Plus mod. And mod. There we go. I forgot. The built-in pow function has modulo support. I shake my head. But hey, it's good because we go through this again. So just remember, it's to raise the base. Okay, it's to raise the base when you do this, and then you multiply by base. That's the key, and then you mod here. Yeah, still not sure if I can remember, but good riddance. Alrighty, that shall be it. Let's see if this is later added. If the monkeys swap places. Oh, that's why the problem's changed, I guess. Oh, they have the second test cases. They probably change a collision or intersect on an edge. Yeah. Alright. I think it's good. Oh, it's because during the contest, maybe this is not included. It's probably got updated. Doesn't matter. Alright, that shall be it. I will see you guys tomorrow. Adios.